Hello. Good morning, everybody. I know. Good afternoon. It's afternoon na pala. Mag-2 p.m. na. It's something like just morning. Anyway. Okay, so I'll begin to continue the rationalization of the gen ed math. So if you're going to finish this, I'm going to upload what's this? The gen ed science. Anyway. Section 2, because I already have done I finished rationalizing the section 1 of the gen ed math. If you don't know where the file is, just find the gen ed math 2018 September, something like that, just below this video. You can find the file. Open that and then try to go over the questions, and while I'm also rationalizing each number here. Okay, so I'm done with section 1. I'll begin to rationalize today section 2. I'll try to reach until section 5. Okay, because there are, I think, 9 sections all in all. Anyway, there you go. So the first one is like section 2, number 1 question. What is the sum of all the factors of 24? So the factors of 24 are, what's this? 1 and 24. And we also have like 12 and 2. And then we also have 3 and 8, and we also have 6 and 4, right? These are the total, these are the factors of like 24. So as you can see there, wait, I'm gonna see your comments. Oh, okay, sorry. Anyway, so these are like the factors of 24, 1 and 24, 12 and 2, 3 and 8, and 6 and 4. Now, it says here that the sum of all factors of 24. So, the sum of all factors of 24 is what? This one is 25. This one is 14. This one is 11. And this one is 10. So, adding all, so we have there how much? 0, carry 1, that is 6. So, the answer there is letter D, which is 60. Okay, there you go. Next one. Next number. We have there, what is the greatest number of 3's that can be multiplied together and still have the result less than 250? Okay, so that means this actually is like, usually you can make this one into like exponential form. So how many 3's are you going to multiply so that the product is still, below 250? So we have there 3 times 3, that is 9. Times 3, that is 27, times 3, that is 81, times 3, that is what? 243, right? 3 times 3 is 9, times 3 is 27, 27 times 3 is 81, 81 times 3 is 243. And so this one, 243 is still less than, because if you're gonna multiply 3 more, this will be like more than 700. So it's not, what's this, 720 or 30 something, or 739 something, anyway. If you're gonna multiply that one more than 250, which is like, what's that? It does not already conform with the condition that's given, which is like 250 or below 250. Okay, so there's like 1, 2, 3, 4, 5. So there are only 5 3's. The answer there is letter C for number 2. Number 3, which of the following must be true about the sum of all the prime numbers between 20 and 30? Okay. So, between 20 and 30, what are the prime numbers in there? When I say prime numbers, there are no other factors except the number and 1. So, what are prime factors, prime numbers, between 20 and 30? So, that's like 21 is a composite number because it's like 7 and 3. And then 22 is 11 and 2. 23 is none, so this is 23. 24 is a lot. It's a composite number. 25 is also composite. 26 is also composite. 27 is also composite, 9 times 3, right? And 28 is also 7 times 4, and that's composite, 14 times 2. 29 is also, okay? And then, anyway, it's just between 20 and 29, so we only have 2 numbers. So the sum of this is equal to, how much is that? We have 52. So 52, what is true about 52? Is it a prime number? Of course not, because 52 is a composite number. When I say prime, again, a number that has no other factors except the number and 1, okay? So, 52, letter A, number 3, it is a prime number. No, it's wrong. Letter B, it's an odd number. No, it's wrong because 52 is an even number. It ends with 2. 24680, a number that ends with 24680 are all even numbers. They're not odd. Odd numbers are like 13579. Okay, so this one ends with 2, so this is even, so B is wrong. C, it is a factor of 156. So if it's like, when you say it's a factor of 156, that means it can divide the number. So 156 divided by 52, that can be 3. Okay, so C is possible answer. Let's go letter D. It is a multiple of 5. No, 52 is not a multiple of 5 because multiple of 5s are numbers that ends with 5 and 0. Next, letter E, it is a factor of 10. No, it's not a factor of 10 because, what says 52 is bigger than 10. Okay? So the answer there is letter C. As I told you that it is a factor of 156 because 156 divided by 52 is equal to 3. Okay, so the answer there is letter C. Next, number 4. At a dinner party, each table can seat 8 people. So if 100 people attend a party, what is the maximum number of tables are needed? So there are like one table, there are 8 people. So 100 people, how many tables do we need? So we're just going to divide this one. What's this? 100 divided by 8. Okay? So this one is like 12.5. So one table has 8 people. And there are like 100 people. So we divide by 8 so we can determine the number of tables. Okay? So there are like 12.5 tables. Or you can say this one, 13 tables. Maximum. Because we cannot have half a table. Anyway, so the answer there is letter B, which is 13. Next one. What is the greatest integer that evenly divides both 48 and 64? When say 48 and 64 evenly divide, that means it calls for a greatest common factor. Okay, so 48 and 64, we just do like this. 48 and 64 we have by 2, so this one is 24 and this is 32. We can still divide by 2, so this one is 12 and this one is 16. By 2 again, we have 6, and then this one we have 8, and by 2 again we have 3 and 4. So these are like the common factors. So 2 times 2 times 2 times 2, that is 16. Okay? So this is the greatest factor, or this is the greatest number, or greatest integer that can evenly divide, what's this? 48 and 64. 48 divided by 16 is 4, and 64 divided by 16, no. 48 divided by 16 is 3, and 64 divided by 16 is 4. Okay? There you go. So the answer there is 16. I have some questions in here that has no choices. It is because I also want you to try to, analyze and try to solve the problem. That's actually my purpose in there. Why I also have posted some questions in Gen Ed Mathematics without choices. Okay? So there you go. Next, number 6, we have there, let P be a prime number greater than 4. So any number that is greater than 4, any prime number greater than 4 that represents P, represented by P. So how many distinct factors? When I say distinct factors, even if like how many like distinct unique factor, or shall we say 9 has only one distinct factor because it's like 3 and 3. 2 3s are just the same anyway. So there's just like one distinct factor, which is 3 in there. Okay, so if it's like 9 times P, how many distinct factors do we have? I told you if P is a prime number, that means P is a factor of itself. Okay, so we have one factor here because anyway it's a prime number, no other factors. It says there in the problem. And then 9P has like 3 squared. So 3 squared, how many distinct factors do we have there? So we have 2 distinct factors in there in 9P. Okay, so there we go. Oh, shall we say, my strategy also with this is like, if you really can't understand, because this problem is really is an abstract problem. When I say abstract, it's really very hard to understand it. It's because it is unclear. So for you to make this one concrete problem or a clear problem, just assign a certain number that can represent the given variable and that also satisfies the condition. So it says here that P is a prime number greater than 4. Shall we say P can be a prime number greater than 4, can be 5, can be 7, can be what more, 11, something like that, and so on. Now, if shall we say P is 5, so that means 9 times 5, because 9 times P is equal to 3 squared times 5. So that's still, there are 2 distinct factors we have there. Okay? So there we go. So any number can represent letter P, as long as it satisfies the condition given in the problem, which is a prime number greater than 4. Okay? Anyway, it doesn't ask about like that, like the prime number, but you can assign a certain digit or a certain like a concrete what's this? Number that could represent the given variable. That will also conform with a given condition. That's the strategy there. If you are really if you are going to meet this kind of questions, these are abstract questions. We call this one like another questions like if p is greater than if p is a prime number and is greater than 60. So you can represent p in any number that also satisfy that's greater than 50 and it's a prime number. Okay? So there you go. That's actually when questions like this, we call this an abstract questions. Okay, next one. Number 7.